Hello everyone, welcome to Stathub, a self-study course on statistics organized by Mathematics Association Unify 2023-2025 of Mattheophilus Training College, Nalanjara. Today we are going to learn about measures of central tendency, arithmetic mean or average. In a nutshell, let me explain the major points that I am going to discuss today. I am going to deal with the definition of correlation, its representation, types, method to find correlation coefficient, and some examples. Now, let us discuss the definition of correlation. Correlation refers to the relationship between any two or more variables. Two variables are said to be correlated if the change in one variable results a corresponding change in other variable. The measure of correlation is called the correlation coefficient or correlation index. It is denoted by R. Also, R ranges between -1 and +1. Mainly, there are two types of correlation, positive correlation and negative correlation. Positive correlation. It is also known as direct correlation. If both variables varies in same direction, then it is called positive correlation. For example, x equal 25, 30, 35, 40, 45, 50, 55 and y equal 18, 27, 36, 43, 55, 61, 70. Here, the values of x and y increases. Therefore, it is a positive correlation. When we see other example like x equal to 86, 75, 67, 63, 54, 53, 40 and y equals 80, 75, 70, 65, 60, 55, 50. Here the values of x and y decreases. That is a positive correlation. In positive correlation, the value of R ranges between 0 and 1. Next is negative correlation. It is also known as inverse correlation. If both variables varies in opposite direction, then it is called negative correlation. For example, the values of x are 85, 80, 75, 70, 65, 60, 55 and values of y are 22, 28, 36, 42, 55, 65, 70. Here the values of x decreases and values of y increases. Then it is a negative correlation. In other example, the values of x are 28, 29, 35, 42, 51, 59, 63 and values of y are 92, 91, 83, 81, 63, 55, 42. Here, the values of x increases and values of y decreases. Therefore, it is a negative correlation. In negative correlation, the value of R ranges between -1 and 0. Now, let's discuss about some other types. Perfect correlation. When values of both the variables change at a constant ratio, irrespective of direction, then it is called perfect correlation. The value of perfect correlation will be either +1 or -1. Imperfect correlation. When values of both variables changes at different ratios, it is called imperfect correlation. The value of imperfect correlation is between -1 and +1. We know that coefficient correlation R ranges from -1 to +1. If R equal 1, then it is a perfect positive correlation. If R equal to -1, then it is perfect negative correlation. If R equal to 0, then it is called no correlation or zero correlation. Now, from this number line, we can understand what is a strong negative correlation, very weak correlation, strong positive correlation. In strong negative correlation, the values we get are -0.8, 0.9, 0.95. In very weak correlation, 0.1, 0.2, -0.1, -0.15. In strong positive correlation, 0.8, 0.9, 0.95. Now, let us see some methods to find correlation coefficient. The first method is Carl Pearson's product moment method, Spearman's rank correlation method, scattered diagram method, and concurrent deviation method. Here we discuss only about Spearman's rank correlation method. So, what is Spearman's rank correlation method? Under this method, correlation is measured on the basis of rank rather than the original values of the variables. The equation for Spearman's rank correlation method is R equal 1 minus 6 sigma d square divided by n cube minus n, where R equal rank coefficient correlation, d equal difference in ranks, n equal number of pairs of observation. We can find R with the help of three cases. Case 1, when actual ranks are given. For that, let us solve an example with this case. The rank of 10 individuals at the start and at the finish of a course of training are given below. And we get a table. In the table, it is given that individual A, B, C, D, E, F, G, H, I, J, and rank before and rank after. We have to find Spearman's rank correlation. To find Spearman's rank correlation, first we have to find the value of d square. And we know that d is difference in ranks, that is d equal r1 minus r2, where r1 and r2 are already given in the question. So, when we take the case of individual A, r1 equals 1, r2 equals 6, d equals r1 minus r2, that is 6 minus 1, that is 5. Therefore, d square equals 25. Similarly, we find all the values of d square of all other individuals. At last, we get the sum of d square, that is 176. We know that R equal 1 minus 6 sigma d square by n cube minus n. When we put the value of d square in the equation, we get 1 minus 6 into 176 by 10 cube minus 10, where n equals 10, which is equal to 1 minus 1056 by 990, which is equal to 1 minus 1.066, which is equal to minus 0.066. Case 2. When ranks are not given. If the original values of variable are only given, they are to be converted into ranks either in ascending or descending order. Let us solve a problem with this case. From the following data, find out rank correlation coefficient. A table is given. In the table, marks in account and marks in QT is also given. First, we have to find out d square. For that, we need R1 and R2. In the question, it is only given that marks in account and marks in QT. With the help of marks in account, R1 can be calculated, and with the help of marks in QT, R2 can be calculated. The largest number in marks in account is 90. With respect to 90, 1 is marked in R1, and the second largest number in marks in account is 88. With respect to 88, 2 is noted in R1, and the third largest number in marks in account is 85, and we write 3 in R1 with respect to 85. Similarly, all other values of R1 can be calculated. In the same manner, R2 can be calculated. The largest number in marks in QT is 92. With respect to 92, 1 can be noted in R2, and the second largest number in marks in QT is 87, and 2 is marked in R2 with respect to 87. Similarly, all other values of R2 can be calculated. Then D can be calculated. We know that D equal to R1 minus R2. Finally, D square can be calculated, and the sum of D square is 4. We know that R equal 1 minus 6 sigma D square by n cube minus n, which is equal to 1 minus 6 into 4 by 10 cube minus 10, where D square equal to 4, n equal to 10, which is equal to 1 minus 24 by 990, which is equal to 0.976. Case 3. When two or more values are identical, that is tie ranks. To find rank correlation, R equal to 1 minus 6 into sigma d square plus 1 by 12 m1 cube minus m1 plus 1 by 12 m2 cube minus m2 whole divided by n cube minus n, where m1 equal number of items which are assigned with first repeated ranks, m2 equal number of items which are assigned with second repeated ranks, n equal number of pairs of observation. Let us solve a problem based on case 3. Find out rank correlation. In the table, the values of x and y are given, where x equal 50, 60, 65, 50, 55, 60, 50, 30, 40, and y equal 10, 20, 25, 15, 20, 30, 35, 5, 7. To find rank correlation, we have to find d square, m1, m2 and m3. The values of x and y are given in the question. With the help of that, we have to find r1, r2, The largest number in X is 65. We call it as 1 in R1. And the second largest number is 60, and there are two 60s in X. That is, one 60 we can call it as 2 and second 60 we can call it as 3. And we calculate the value of R1 as 2 plus 3 by 2, which is equal to 5 by 2, which is equal to 2.5. Therefore, the values of 60 in R1 is 2.5. And we call this 2.5 as M1. And the next third largest number in X is 55. And 55 is the fourth number, so we call it as 4 in R1. And the next largest number is 50. There are three 50s in X. So we call one 50 as 5, second 50 as 6, and third 50 as 7, and we calculate 5 plus 6 plus 7 by 3, which is equal to 6. And the values of 50 in R1 is 6, and we call this 6 as M2. Similarly, we can find other values of R1. Next, with the help of Y, in the same process, we can find R2. Then we can find D, which is equal to R1 minus R2, and finally D square, and the sum of D square is 34.5. Also, M1, we get 2M1, that is 2.5, which is M1 equal 2 times. M2, there are 3 M2s, that is 6, therefore M2 equal 3 times. M3, there are 2 M3, which is 4.5, M3 equal 2 times. We know that R equal 1 minus 6 into sigma D square plus 1 by 12 M1 cube minus M1 plus 1 by 12 M2 cube minus M2 plus 1 by 12 M3 cube minus M3 all divided by N cube minus N. By substituting, R equal 1 minus 6 into 34.5 plus 1 by 12 2 cube minus 2 plus 1 by 12 3 cube minus 3 plus 1 by 12 2 cube minus 2 all divided by 9 cube minus 9. By solving this equation, we get 0.688. So today we discussed about correlation, correlation coefficient, types, method to find correlation coefficient, and some examples. Hope you all have understood the topic. Thanks for listening.